Okay, guys, videos round two. Um, so I've gone over what we've done so far this week. Coming up today, so for Wednesday, what we were going to originally do was kind of a two-parter. So first thing I was going to have us look at, and this was a higher priority for me, was this idea that's called powers to powers. It's pretty straightforward. It's a little weird, but it's not bad. So you guys remember how we've had a few problems where we've had, like, for example, like -9 was the base and we had some kind of an exponent on it. And I was saying we should treat whatever we have in parentheses as our base. The same thing is happening here. We have a base in parentheses with an exponent on the outside. Now I can already hear, like if I was in class, I'd probably have someone going basically, but mister, there's an exponent inside the parentheses. Don't care. We're just kind of ignoring that for the minute. What this problem is going to have us do is we're treating 5 to the 4th as our base number. So we're going to, ooh, that's an ugly 5. Take 2. Oh, yep, that's a better 5. We're going to have 5 to the 4th in parentheses multiplying itself 3 times because I had an exponent of 3. And I'm sorry, this is coming out less than perfect. So 5 to the 4th for a third time. And we need to remember, guys, when we have parentheses touching with no math symbol written, that was going to change colors and be fancy, but I can't change colors at the moment. Yay, glitchy computer software. The math that exists between these sets of parentheses is multiplication. And when we are multiplying our like bases with exponents, we are just going to add our exponents. So what we're really doing here is 5 to the 4 plus, come on, little tiny plus. Yay, I made it work. Plus 4, plus 4. Ooh, that second 4 was really quite nice. I might almost be getting good at this. Queuing third 4 to be bad. Nope, it was okay, cool. So we're doing 5 to the 4th plus 4 plus 4. And that would give us a 5 to the 12th. So we already kind of knew what was happening here. But here's the thing. What if we had something that was like 4 to the 3rd in parentheses and the exponent on the outside was a 10? We don't want to have to write out that 4 to the 3rd in parentheses 10 times. So there's a shortcut. And not being able to change colors means I can't change to the eraser either. So just kind of ignore this for the minute. What we would do is back at the original problem. Again, I can't erase, sorry. Actually, one moment, you might notice a stutter in the video. So I was able to make the computer start to like me, and the video picked up again. Yay. So what we're going to do here is basically what we have is multiplication. Think about it, guys. Repeated addition is multiplication. So we're really doing 5 to the 4 times, I'll put a little x because that's easier to see. Oh, maybe that's not easier to see at all. 1 second. 5 to the 4 times 3, which is going to give us, again, our 5 to the 12. So that's what we're looking at. This is what power to a power is. Because we could go ahead and do this, but we don't want to, our shortcut option is basically, hey, how do we do repeated addition? Repeated addition, we should know is multiplication. So we just wind up multiplying our two exponents to get our answer. So down here, what this is going to be is 7 to the 8th times 7 to the 8th in parentheses with the second power on the outside. We're going to just multiply our exponents. So I'm just going to have this is equal to, Actually, let me change colors entirely so no one gets confused. 7. This is equal to 7 to the 8th times. Come on, make a nice little X. Yay, it sort of worked. 2. And that's going to equal 7 to the 16th. So yay! That's the first step. Oh, hang on, I think I hear real life happening. So if you hear a kid in the background, sorry about that, but you know, life's happening. I'm just getting these guys done for you as quickly and efficiently as I can. So guys, what we've got, big surprise, I showed you how to do it. I've got a few problems for you to try out. What I want you guys to do, is just give these 4 a try. Feel free to just pause the video, take these 4 problems that you see, give them a try. I'm going to just wait 5 seconds till my kid is happy. I'm going to go, Dad, you do these problems. See you in about 3 seconds. So guys, you've always heard me say I put dadding as a priority. Some days the way to get it done is you just got to take a minute and have your kid join you. So yes, this is where everyone's brain suddenly melts and goes, oh, yes, this is my smallest. This is Lincoln. So you've had a moment to do these problems. I asked you to take a look at them. And by Lincoln's request, I'm writing in rainbow. So should be okay to read. So this 11 to the 5th in parentheses, there are 2 on the outside. Again, we're just going to be multiplying our powers. Ooh, that is an ugly one. And you're going to wind up essentially doing 11 is your base, but your exponents of 5 and 2 multiplied to give you a 10. There we go. So the next one is 12 to the 8th to the 3rd, in parentheses, to the 3rd power. So again, we'll just keep our base of 12. You pretty much always keep your base. Well, that was not a very good 12. Lincoln, is that a good 12?
No.
No, it's not. Okay. So the 3-year-old has spoken. That was not a good 12. There's a better 12. So 8 times 3 is going to give us our new exponent of 24. Whee! And 2 to the 10 in parentheses with an exponent of 4 on the outside is going to be, and yeah, that stutter was me having to pause again. So our base is, as I hopefully said, 2 with an exponent of 40, because again, our exponents of 10 and 4 multiply to give us our new exponent of 40.
I want to pick a different color.
Okay, Lincoln, what color should we pick? Orange?
That's not my favorite.
What's your favorite then?
My favorite is white.
White? Okay.
Yeah.
Apparently, this is your favorite color. News to me. So, last problem. We're going to have our base of 20 stay our base.
That doesn't look like a good squiggly line.
Yeah, that's a good squiggly line, but it's not a good 2. Boop, that's a better 2. And then an exponent is, or not an exponent, 20, a 0. So now we have our 20. Our exponents of 7 and 3 multiply to give us our new exponent of 21. I hope you guys found this not too bad. Sorry for the interruptions and the random distraction posed by child. I'm going to be doing another video. It will be covering some issues people were having with Delta Math, and I will be featuring some of this on Delta Math. Lincoln, can you say bye?
Bye.
Can you say bye-bye?
Bye-bye.
That wasn't much of a wait, but okay.